Ladies and gentlemen, good morning. It is my pleasure to be able to welcome you to the second day of the conference. And I'm very happy to announce our opening keynote for the day, Zvonimir, who will be presenting the Pythagora, I guess we can call it a framework, right? What? Platform. A testing platform called Pythagora. And if we can just lower the volume a bit. Thanks. So, Zvonimir, take it over.
Thanks, Weber. Thanks everyone for coming. As Weber said already, my name is Zvonimir, and today I'm going to talk to you how are we trying to make automated tests autonomous, and we're doing it through open source. So first time when I spoke with Weber, when we arranged this talk, actually the topic of the talk was supposed to be how to get from 0 to 80% code coverage in 30 minutes. And while Pythagora still does that, we have shifted in the last couple of months lots towards the LLMs. So I thought it might be even better to show you maybe how are we trying to basically cover automated testing with LLMs and all the new technologies that are becoming available. So a little bit about myself. As I said, my name is Zvonimir. I'm actually a FAIR alumni. I finished FAIR quite a long time ago. But also I'm an ex-founder. I created one startup which I sold 2 years ago to Miro, and I took a year off basically after the acquisition to get more into machine learning and to try to understand really advancements in AI and how to train the models, how to test them, and all the different things. And then 1 year ago, a little bit more, I decided to start my next company. And this is actually what led me to Pythagora and to open source. So why automated testing? So I always, before when I was leading the technology teams, I would always have problems with automated testing. If any of you is not completely aware, I know that everyone here is technical, but maybe some of you might not have commercial knowledge, commercial experience. But automated testing is basically a separate code base from the original product, which basically doesn't do anything for the end user, but basically what it does is just test the product, the original code base, to make sure that it works correctly all the time. And basically in well-funded teams, they spend 20 to 30% of their time writing and maintaining these automated tests, while still I made a poll on Reddit, and basically 75% of developers said that they really hate working on automated tests because they just don't have impact on the end user. Like if you have the application that has millions of users and you created this test suite and you work on it day in and day out, it has no impact on those millions of users, but only it has impact on the original code base. And so after that year of getting into machine learning, I started to think, like, how can we combine machine learning and automated testing? Because for me, it is still in like commercial applications, it's still kind of looked at as a luxury, because first you get a QA team, couple of testers that just manually test your application, and to get automated tests set up, you need to get developers engaged, which are obviously more expensive, and it kind of always end up being like the last priority, while it's still much better than having someone clicking manually through the application. So I thought, like, how can we combine these two fields and basically make automated tests fully autonomous, right? So this is a little bit about our path, how we got to Pythagora. So first thing that we did is we tried to automate visual testing. So the idea was to get an ML model to analyze the website on all the different resolutions and basically try to compare it to the original design that was created by the designer, and it would try to find all the things that are not in place as they should be, like buttons being off and things like that. And it worked like surprisingly well for my perspective, but we realized, and this is a little bit of like a startup way of doing things. We talked to users, and it ended up being that is not big of a problem to developers. You know, if you have a button which is a little bit off to the left or right, it's not that big of a problem. And everyone told us, like, hey, we need functional testing. We need to check the functionality of the application and see if the application is working correctly, and not if a button is a couple of pixels off. And then we created an algorithm that would do monkey testing, if anyone is not aware. So monkey testing is basically just randomly clicking throughout the application, trying to do some unusual things that users might not do, but still might uncover bugs on the application. And while this was able to discover pretty meaningful bugs, like for example, we were able to discover like forms that are not working, buttons that are not working, the code was running pretty slow. It would take maybe hours and hours to just test one single page. And again, we talked to users, and everyone said, like, okay, this is a problem, the time constraint, but again, we don't know what is tested, right? If you have this monkey who clicks around the application and says, like, okay, our application is working correctly, you're not sure what exactly is working correctly. So we created this kind of a prototype for proper functional testing, and the idea for that was that you have an HTML snippet that is similar to Hotjar or Full Story, if you is familiar with these tools. So basically that's a snippet that you put into your website, and what it does, it tracks everything that user does on your application. Like these tools that I mentioned, they're for marketing purposes, so you understand what are users doing on the application, on the website. But so what we wanted to do is we wanted to track everything that's happening on the production, and from that basically create a set of tests that are most meaningful to this specific application, right? And this way we would cut down that running time, and also we would be able to show users what is being tested and what is the impact of all these tests. However, when we got to this, we created this prototype and everyone was excited, we talked to users, but then we got to a technical problem, and that was we didn't have control from the front end, we didn't have control over the back end and the database state and the server states. So for example, if I'm a user, if I click something and some pop-up opens up, this pop-up is likely related to my specific user state. So for example, I might have a subscription, might have a payment that didn't go through, and a pop-up would say, like, hey, your payment didn't go through, you need to update your payment details. And for that, we needed to have that specific user in the database, a payment document in the database, and everything that's related, so that this specific pop-up shows up. So we decided to transfer over to the backend and create something that would encapsulate the entire backend and is able to mock everything outside of the actual code that is running. For example, database, third-party API requests, and so on. And that is actually how Pythagora came to be. And from here, we actually wanted this to be just a part of our solution, but it ended up being pretty users were basically pretty happy about this and really wanted us to continue in this path. So that's how we continued to work on Pythagora itself. So what is Pythagora? Pythagora is a platform that basically encapsulates the entire backend. So it tracks all the server activity that is happening during the capturing phase, so that when you run the test, it runs your JavaScript code, it runs an API request, JavaScript code or any other language code is being run, but everything outside of that code, for example, database queries, third-party API requests, and so on, everything else can be mocked by Pythagora. And the idea was that we cut down those 20–30% of developers' time down to 0.1%, so the developer only thing that he needs to do is just check what the test is being recorded, and that's it. So Pythagoras tests are much more detailed than what developers create, because just it takes so much time to write all the code. So that Pythagoras tests cover much more of the use cases and have much less bugs in the code. And with that, we're expecting to have a better developer retention, because developers are able to work on the original code base which they want and not on the tests themselves. So before I get into where are LLMs here, I want to show you just a little bit more in detail how does all this work. So here we have two diagrams. These are two phases of Pythagoras. So one is capturing phase and one is testing phase. So the idea is that when a developer creates, for example, some endpoint that does something on the backend, what they do is they just run their application. Currently we're working just in Node.js, but obviously we're looking for expansion later on. So what they can do is they can just run their application, but wrapped by Pythagora. So for example, if you're running your application with npm run start, what you would do is just run with npx Pythagora init command and then npm run start. And that would run your own application, but wrapped with Pythagora. So what happens after that is that developer needs, or you need to just make an API request to the backend. And when Pythagora captures that API request, it starts tracking everything that's happening on the server during the execution of this API request until the response is returned to the front end. So that includes, as I already mentioned, like external libraries and vendors. That means like third-party APIs, databases, and all those things. And for example, here you can see like all these dots. They're basically intersections that that Pythagora captures both the requests towards the external service and the response that our external service returns. And during the capturing phase, Pythagora only captures all the data, so that later on, what only thing you need to do is you just need to run Pythagora test command, which is literally just one command. And what it does, it sits on all these intersections, and Pythagora sends the API request to the backend. Or again, it's wrapped with Pythagora. Then everything that goes outside of the application itself, first, it is being mocked. For example, like third-party APIs, like if you're using Twitter API or any other, that will be mocked. While for the database, we had a little more complicated system, because integration tests, if any of you is familiar with them, they need to check if the database is updated correctly. So for example, if you have an API endpoint which updates the database, you want to check if the database is updated correctly after the request is being processed. So that's why we actually create this temporary database, Pythagora DB, in which Pythagora restores the database state which was present at the moment of the capture. So obviously that doesn't mean the entire database, because it would be just too large, but only the documents that were used during the processing of the request. It restores it to this database so that Pythagora can interact with this database as any other database, but after the request is being processed, Pythagora checks if the database is updated correctly. So this is basically how Pythagora works, and this is our initial idea, which you don't need too much of machine learning, a little bit, but not too much. And this is how it was running at this time. So this is how Pythagora tests look like. So you will see it is pretty quick. So these are, I just quickly captured these like 30-something requests and just ran them for this demo. And you can see here we have, I believe, like 36 tests, all of them pass obviously, and they ran in 0.37 seconds. So it's pretty quick. Within like 10 seconds we can have thousands of automated tests running. So this is one thing that we weren't able to do with all the previous iterations. So we're pretty happy about this. But what happened, just a second, I'm not sure was this. Let's do this again. But what happened while we were developing Pythagora, I had one task to do. So if you see this this entire schema, so here's the database, and like we started off with Mongo database, and it was pretty good because it had its own structures like middleware, so where we can pipe Pythagora into. But we wanted to support Redis as well. For those of you who are not familiar, Redis is an in-memory database, which is very simplistic. It's very super fast, so it doesn't have all these like big concepts like middlewares and all these different things. So we envisioned that we need to create TCP proxy that would sit between the Node.js application wrapped with Pythagora and the Redis itself, and it would capture all the requests that are going towards the Redis and all the responses that Redis is returning. And for that, I thought to go really low level, like on TCP level. But to be honest, I worked with TCP the last time I was here on Fair, and I just know the basic concepts. I don't know how to get it up and running, and I went to use some libraries. Most of them were in C. Again, I used C the last time when I was in college. And I tried to hack it somehow, and I spent 2 days on that and just couldn't do it. I just couldn't make it to work, like all those memory allocations and all the different things that just like modern frameworks like Node.js just you don't need it for. And after those 2 days, I said, okay, I can't do this. I'll get someone from Upwork to do it. If anyone of you is not familiar with Upwork, that's a marketplace for freelancers where you can hire someone to do like one-off job, and there are a lot of developers there. And I thought, like, let me get someone from there, and I got a lot of proposals. Mostly they were between like $600 and $2,000 to $3,000 for this specific script, basically. And I was thinking, like, should I do it? Like, I said, like, oh, let's try and go with this one guy for $600. And literally just before I made an offer to the guy, I thought, like, hey, why don't I? At that point, GPT was pretty new, and I thought, like, hey, why don't I try to do it with this Chat GPT thing? And after that, I spent 2 hours going back and forth with ChatGPT, and to my like really big surprise, after those 2 hours, I had a script that was working fully automatically. It was working as expected. It didn't have bugs. It was debugged. Everything was working after just 2 hours. After I spent 2 days trying to do this, and I got offers, as I tell you, and all the developers who know how to do it, they were offering basically like 20, 30 hours to make this script. And even after that, like I was really like surprised with it, and I created it in Python. I know Python somewhat well, but I thought, like, hey, this whole thing is in Node.js. Why don't I tell GPT to just convert it, to translate it to Node.js? To be honest, I didn't even know that like frameworks like Node.js have ability to go to the TCP level, but I thought, like, hey, let's try it. And it literally took me like 5 minutes, couple of messages with ChatGPT back and forth, and I had fully working script in Node.js, this proxy that I was telling you about. And I was really mind blown by this. I was like, how can this be possible? Then I got much more into whole LLM space. And from then, as you can see, there are a lot of advancements in this space. I'm pretty sure that all of you are familiar with it. We got PaLM. Literally like 2 days ago, Google released PaLM 2, which I'm still trying to get early access to see what's it about. But obviously we have GPT as well, and we have Llama, which is open sourced by Facebook. After that, we started to work to test out some of the things. We continued the development of Pythagora, but we, in parallel, was trying to see what are the possibilities with these technologies. How much can we, how can we make Pythagora better with these technologies? So we ended up actually trying to create automated integration tests in Jest. So Jest is one framework for writing automated tests, which developers just use regularly. And we were trying to get GPT to actually create this full automated test from our prompts. And this is what I wanted to show you a little bit. It might be interesting for someone. What kind of prompts are we using? So when I started to work with ChatGPT, my prompts were basically as if I'm asking someone a question. I didn't take too much time to do it. I would literally just write a couple of sentences, and they were like pretty short, just try to get an answer and see if it can answer that. But we started to test more with longer prompts. And here I want to show you how our prompts look today. So this is a single prompt. As you can see, it's almost 3 A4 pages long. And this is all text that we have written. This is without the data that we're sending it. Inside this test, you should see here we have test data. So here we add the JSON data from Pythagora tests, everything that Pythagora captures, we put here, and along with this entire prompt, which as you can see, it's pretty big, like we're basically explaining more and more to GPT what it needs to do, how it needs to do it. And after all this, we're still testing this. I'm hoping that we will release this maybe even next week or a week after that. But right now, what we have is basically tests. It looks like this. So as Pythagora is open source, it's used mostly in command line. And here you can see that if you just ran one export command to export Pythagora test to Jest, it uses GPT, and this is the output. And most of you might have seen this. If you go to ChatGPT, you ask it to code something, it will code out things like this. But what is really important here is that right now we're getting 95% of tests that are created, they work they don't have any bugs. So this is not something that, when I worked on the Redis proxy that I was telling you about, I would get a whole bunch of bugs. I would need to, go back and forth and fix bugs. This works in, as I said, 95% without any bug. It literally, you click export, we create this big prompt, and we get test exported, coded test exported, which actually just works. And so this is basically what I kind of wanted. At first, I wanted to talk to you more about Pythagora and what we're doing, but with everything that has happened in the past couple of months, I basically wanted everyone, if you get anything out of this talk, I would say it would be that these LLMs are really, really powerful, and we're experiencing this tectonic shift in software development. I know that many developers will say, like, hey, like it doesn't do correct code, you need to debug it, it will replace junior developers and things like that. But from my experience, and not only the Redis proxy, many different things when we needed to do for Pythagora, because the tech behind Pythagora is relatively complex. When I was coding it, I would talk to ChatGPT, and I was trying to get it to do some things. To be honest, I felt like a junior developer. I felt like someone who takes what GPT tells me, I put it into the code, I run it, I see what are the errors, I tell that to GPT, I maybe debug some things that are easy to debug, but more high-level things were basically created by GPT. And yeah, so basically I wanted to just focus a little bit more from this talk on GPT and what is happening in this whole space. So back to Pythagora. So where are we at right now? So what are we trying to do? Again, this is for some reason messing with me. So what are we trying to do? So right now we have this quite simplistic platform that just tracks API requests and is able to create integration tests, or actually API requests, out of all the server activity. But what are our plans as we move forward is, since we're tracking all the server activity, we're not tracking just the database queries. We're tracking how variables are propagating throughout the code. So, for example, here is just an illustration of a couple of functions, and we have in each function, we know variables that are being sent from one to another, maybe global variables if you're not using it. If you're using it, I mean, you shouldn't, but still, if you are using it, they're also stored as well. And from all this data, what we started to do is test how GPT is able to create, or maybe I should use the term LLMs more, because I'm hoping to use other as well. But what kind of tests these models can do outside of regular API tests? So for example, I wanted to show you one example here that we have. This is another test. Again, prompt is pretty large, so this is with the data that we're sending it. And in this specific case, what I was trying to get GPT to do is to create negative tests. If any of you are familiar with negative tests, those are tests that usually break the server. For example, if you make an API request for an order that is not present in the database, you want to check how does the server work in that case. And for example, what I told GPT to do is and this is really simple, likely in the future we will make it much more complex, likely it will output some JSON object, but still, I told it to, above each test, that it adds a comment in which it specifies what Mongo documents does it want to have in the database for this specific case. Just to tell you, so all the Mongo documents are being sent to the GPT. These are all Mongo documents that Pythagora captured during the capturing phase. So that I told it, like, hey, can you tell me what Mongo documents do you want to have in the database while a specific test is being run? And for example, here you can see, amongst other things, if you saw like how Pythagora tests look like, you can see if not sure why. If you ever wrote integration tests, you will know that all tests just need to have proper names. When something fails, when something passes, you want to know straight away if what failed and what passed. And with Pythagora, we are just unable to get all those information just from the code. So Pythagora tests, they look like this, right? So we basically just show the endpoint that was tested, right? And what GPT does, and by the way, I didn't even instruct it to do that, but obviously it adds the proper test name. It tests what is being tested in that specific test, but also what it can do, and it's working, and this is really, we didn't do a lot of experiments with this specific type of testing, but it still works. For example, it can say, like, okay, don't put the number 1 index, that's the order in the array of all Mongo documents. The index 1 has the order, and it said don't put the orders, just put 0 and 2, indexes 0 and 2 documents, so that we can test what happens when order is not found. And these are the things that just surprise me literally day by day as I'm testing all these things. It just surprises me how well it can do many of these tasks. So this is just another example of what it can do, and what we're trying to do is just use it as much as possible and create all the different kinds of integration tests outside of just API testing. And finally, if you remember, as I was talking in the beginning, so we started off from the front end. So our idea is in the future, once we cover all these different things, we can actually cover the front end as well. Once we have the control over the back end of the database states and everything that's happening there, what we can do is we can actually track what people are doing in production on the front end, cut down all these different user paths, and create fully automated end-to-end tests that have all the database states on the back end, and we can reproduce them, and we can capture and just have them in the test suite without the developer having to write a single line of code. All right, so that's basically it from me. I just wanted to tell you, so we're still super early. We're out for maybe a couple of months. What we're super grateful for is feedback. So if you have any feedback on anything that I've said, I'll be more than happy to hear even right now, or after the talk, if you just ping me, I would be super happy to talk to you and just hear what you think about all this. So yeah, that's it. And now if you have any questions, feel free to ask.
I have a question. In your capturing phase, what kind of data do you capture? Is it just request and response, or you capture anything else, like timings, how long the requests take to the database or to a certain API endpoint?
Yeah, so we definitely captured, the time, how long it took for the API request, but we capture much more than that. As I was saying, we capture all the requests that are going to the database. So for example, if you have a database query, that will be captured. If you have a request towards the third-party API, that will be captured as well. However, what we are playing with right now is capturing all the variables as well. We have the code in place, but obviously once we still haven't deployed this because we don't have any need to, but we're tracking that as well.
And you're capturing like all the query timings or just the request timing? So you don't know, you don't know how long the request to the database took or how long the query took.
Sorry?
So you're making a request to an API endpoint that makes a, I don't know, select on a database. Mm-hmm. Do you know how long the select took, or you just know how long the whole request took?
To be honest, we are not tracking times that much. We're not comparing them, but we definitely can. It literally just adding the timestamp, and we know when the database query is being made and when the database returns the response. We have both those times, so we can.
Yeah, I'm just asking, if it's possible to extract those values somewhere and then do some analytics on them, like for APM or something like that.
Exactly. Yeah, for sure. APMs do that as well. For anyone who's not aware, APMs are application performance monitors, and basically they track exactly that. If you have a holdup in any part of the system, for example, if a database query just takes too long, we can track that for sure, but I don't think we'll be focusing just because you have so many other applications. Yeah.
Any more questions?
Just capturing the request response seems a bit quite like static case. Do you maybe have any plans or ideas or options to add some sort of fuzzing to that request to test some additional cases?
So first off, we're not just using the request and the response. As I mentioned, we're tracking even the variables throughout the code. One thing that I can say is that what we have tested with is, again, with GPT, is creating those negative tests. And by negative tests, I created this kind of a script It's kind of clumsy, so I didn't deploy that. We'll likely do something with it in the future. So what we did is we gave the data that is going towards an API request to GPT and told it to give me all the possible negative values that can be, for example, if you have one parameter, price, it's a number, a negative value would be a string for that specific parameter or an array, object, whatever. And with that, what the script did is it did all the different permutations of what GPT returned, and that way we're trying to break the server, and actually it worked somewhat well. You could do permutations from everything that GPT returned. It would create, I created, at least for one repository, 2,500 different requests, and out of those 2,500, 3 of them broke the server. So this is kind of the variance that you might be thinking about. Anyone else?
Thanks. Hi. Does it only support Node.js or any other? Is it just wraps around the TCP and you do some kind of
obviously it has the Node.js code as well. So currently we're supporting only Node.js, and this is just for us to create this MVP, if anyone is familiar, like minimum viable product, just to test how it works on the market. Specifically with these kind of things, I think that our main goal right now is to understand what do users, the developers, how the developers want to work in this kind of a new, I would say maybe new era of generating code, because in the next few years there will likely be more and more code being generated. We're trying to understand how do people want that to be generated, what is acceptable, what is not acceptable, and because of that we're focusing only and solely on Node.js for now, but in the future definitely other languages will be supported.
Please do.
For sure. Yeah.
Any more questions?
All right.
Seems like no. Okay, thank you very much.
Thank you.